Welcome everybody to the 2020 Design Slam at Autodesk University. The 2020 Design Slams calls on AEC professionals to imagine a more resilient future through the use of technology at an iconic urban site. This year, we're introducing a new format, a Design Slam Masterclass. I am Cesar Escalante, Technical Marketing Manager at Autodesk, and I will be your host today. Previous Design Slams, which have been running since 2008, focused on a timed competition to bring participants together in front of a live audience. Participants would be asked to test their problem-solving skills around a fun, fast-paced design challenge. As a Design Slam veteran, I'm disappointed I will not get to see you all at what has become a signature live event at Autodesk University. We don't have the energy nor the vibe of the room this year, but I'm very confident that this year participants, Walter P. Moore and HOK, will demonstrate to the world how their use of technology shaped new ways to arrive at a smarter and sustainable solution. This Design Slam Masterclass edition will be more focused on exploring the process and design thinking of industry experts. The format of this masterclass is as follows. Each designer will be given about 20 minutes to represent their team and their approach. I will interact with the participants at some point to dig deeper into their design process. At the end of the presentation, there will be an open question and answer period. We encourage you to enter your questions in the chat features of the streaming platform you're watching. This year, we're giving our participants the chance to strike on their unique approach to designing at an iconic site, New York City's Governor Island. Sitting in the heart of New York Harbor and just at 800 yards south of Lower Manhattan, Governor Island is the target of a new set of regulations that will allow for an expanded development effort. As a general disclaimer, Autodesk is not affiliated with any of the processes currently underway to redevelop the site at Governor Island. We're simply captivated by the opportunities of the site because it embodies the many challenges designers face in today's complex world, like climate change, rising sea levels, housing crisis, environmental justice, access to green space, just to name a few. We ask our participants to explore the idea of resilience. What does that mean in 2020? What does it mean for a future site within a mega urban infrastructure? We ask them to arrive at a design solution from an integrated, multidisciplinary design approach through the use of computational design method and design technology processes. Since becoming a public land, Governor's Island has undergone a wide-ranging transformation over the past decade, including a multi-million investment in Hills Park, a 43-acre public space that opened in 2016. The southern track adjacent to the Yankee Pier is currently the target of new regulations that will allow for mixed-use development. At the heart of this development, a redesigned ferry station and a new climate change center are considered as the signature programmatic elements. We have asked our participants to share their vision on what this new development should look like. The challenge imagines a resilient, transit-oriented development along a revitalized waterfront. Participants are asked to document their creative process on the following: a vision for a climate change research center that includes a facade design that balances energy and thermal performance, systems that target net zero energy, a structural design that targets the resilience to storm surge and a rising sea levels, public waterfront amenities, and a redesigned ferry terminal station. So with that said, I'm very excited to introduce our first participants. Steve Smith is a senior technical designer at Walter P. Moore. He brings 20 years of experience designing entertainment, performing arts centers, and sport facility. Steve leads the Walter P. Moore Parametric Modeling Group. Steve, welcome to the Design Slam. How are you today?
Hey, Cesar, it's good to see you again.
Great. Steve, tell me a little bit more about Walter P. Moore.
So Walter P. Moore is a firm that's made up of a lot of different architects and engineers and designers and different smart people who are innovative and inquisitive and forward thinking. But what I really like about working here is that there's no egos. People like to help each other and to collaborate and solve complex problems, whatever is needed by the client. And this helps to create a culture where everybody can do basically what they're good at and what they're passionate about. Um, when I was invited to participate in the Design Slam, I thought that this was going to be 30 minutes to show just my dynamo chops. But then I saw that we were going to need a bigger team. So fortunately, we were able to collaborate across offices and disciplines, and we assembled a team of 9 people, and then began determining our scope. We quickly realized there were some challenges here. We could see that the site is an island, so there was going to be problems with getting materials there, but also the risk of storm surge is great. So we looked at an 8-foot storm surge with a 5% probability. That's a 20-year event. And we also looked at a 10-foot storm surge, which would be like a 50-year event today. But as sea levels rise, we expect the 10-foot storm surge to be more like a 20-year event in the future. Now, the center itself, it presented its own challenge because at Walter P. Moore, we're an engineering firm. Usually an architect comes to us and they have a design already in mind, and we just figure it out. Well, we didn't have that to start with. But fortunately, one of our senior technical designers is in New York City, and he's an architect. So Jared Friedman helped us come up with a compelling design here for the Center for Climate Change as well as the site. And from a sustainability standpoint, we decided to reuse some of the existing brick structures on the site. The third challenge that we had here was a transportation challenge. So we consulted with our infrastructure group at Walter P. Moore, and we looked at maybe extending the subway service. We also looked at building a tunnel underneath the harbor there from Brooklyn to Governor's Island. But then we started thinking about how part of the charm is the ferry ride. And there really aren't cars there. That's something else that's nice and unique about Governor's Island. So we settled on a boat to bike concept, adding a new ferry dock with a bike rental shop and a cafe.
I'm really, really impressed by the integrated approach of your design solution. Maybe we can dig a little bit more about that. Steve, how do you measure value and success at Walter P. Moore's digital practice?
Yeah, so that's an interesting question. So like other firms, we do embed loggers and whatnot inside of our definitions so we can see what's being used, who's using it. Then we're able to parse that data with Power BI to kind of see trends when it comes to what's actually being used. We also ask our project managers to rate each one of their projects based on its digital activity or digital practice. So 0 being that it's completely manual, there's no digital practice, and then the other end of the spectrum being that it's completely digital. Now, as far as success is concerned, I don't think that we quantify it necessarily that same way. Success for us has a lot more to do with our client experience. So, did we adhere to the budget? Were we able to make our project partners happy with what we delivered? Perhaps we were able to deliver more to them earlier. Were we able to accelerate the schedule? Perhaps we were able to limit RFIs, or we were able to solve problems digitally before they actually arose out in the field. And so I think we measure our success a lot based on repeat business. And internally, it's when we do get that repeat business, are we delivering more to them each time that we're hired? Are we always increasing our value to the client and to our partners?
And I assume technology plays a big part on this measurement of success.
Yeah, I would say to an extent. You know, like I said, we have the loggers and stuff. We're able to look at all this data, and then we're also able to track the projects themselves that are more digital. Because they're more digital, then we're able to see, what the um, I guess how the I'm trying to think of the right words here. We're looking for patterns, basically, of what we would validate as a success if the customer keeps coming back or whatnot.
Fantastic. I'm eager to hear more about your process. Let's continue.
Okay, so with this next video, we're now moving into the modeling of the site. While I'm a structures guy, I really like to see what's been designed in the structure. But I'm also quite aware that most people ooh and ah over the actual facade or the exterior of a building. So we had two goals when it came to coming up with an enclosure system for this building. First, it had to be visually appealing. But then second, we wanted to show off the complex structure behind the facade. So this is where our enclosure engineering group really came to our rescue. They helped us with optioneering, coming up with 3 options, with the selection of the materials and evaluation of the materials, and then even helping to influence the sustainability. So here we see the first option, which was a curtain wall and precast concrete system. The second one is a precast concrete terracotta curtain wall system. And then finally, a precast terracotta diagrid. Using the 3 design options and their data inside of Revit, we're able to examine sustainability by creating lifecycle assessment reports directly from the data in Revit and exporting that to Tally. These reports help us to visualize and evaluate the impact of the facade. It also helps us to understand a little bit more about what embodied carbon is doing inside of the cladding system, but we also examine the manufacturing process, the installation process, how much embodied carbon is involved in the transportation to the site. And this is all with a focus on circular economy principles. At the Welcoming Center, we created adaptive components representing the modular precast columns. This was driven mainly by construction logistics, with the site being on an island. For the Welcoming Center, for the roof here, we developed a mass timber solution with a warped green roof. Now, it's a lightweight green roof that happens to have a form of moss on the top of it. And you can see we modeled this inside of Dynamo. In addition to this, we also modeled the dock, the piers, bike rental shop, the cafe, and all of this, the Welcoming Center, the Center for Climate Change, the dock piers, bike shop and cafe. It was all done in about 8 hours, 8 man hours. We actually spent more time planning it than actually modeling it. Something that we've been excited about is Autodesk's partnering with Unity. A lot of the AEC community has been viewing VR or virtual reality as a toy or as a gimmick. But using Unity, we're making VR a valuable tool and a part of our design and coordination process. We've developed our own tool set that has assisted with this. You can see here we're able to, Karis is measuring out a truss. She's sketching it actually in VR. And imagine being able to sketch this in this space. We can zoom out, and then we can start cycling through the different facade systems and see what that actually looks like behind there to help the owner come up with a solution. And finally, for the modeling of the Center for Climate Change itself, we're using Rhino inside Revit here to create repeatable geometry. We're referencing the grids and the levels that we're defining our structure directly from Revit. And then you can see on the canvas here inside of Grasshopper, we're using a representative sketch in order to lay out this definition. It makes it easier to follow if others happen to want to come on board and add something, but it also aids in troubleshooting down the line. And so at the end of this entire process, this is everything that we ended up modeling digitally. Nothing was manually modeled. And you can see our structure with the enclosure there.
Fantastic. I'm really enjoying the way in which Walter P. Moore managed data via computational methods and the wide range of tools that you play with. But let me ask you a little soul question. What is the ethos, design technology ethos of Walter P. Moore? What technological processes you think differentiate you from other firms?
Yeah, that's an interesting question. I think that there's 2 things. I think that probably the first thing that differentiates us is that we don't have some exclusive group of technology experts that build all of these digital tools. That's wouldn't be really true to our culture. We want everyone to be able to play. So if you're passionate about this, you want to get involved, you can. But a lot of our development actually occurs on projects. So once we have started developing some of these tools through projects, then we look to share them and scale them throughout the company. The second thing that probably makes us different is our focus on the deliverable itself. We're committed to delivering models to our partners downstream that are machine readable and fabrication ready.
Fantastic. I think you have more of your work for us. Let's continue seeing your work.
Okay. Well, as we move towards delivering buildable models, the data becomes even more important. So, for example, here, Secure Design simulated multiple blast load studies around the Center for Climate Change. In this animation, it's a demonstration of a pressure impulse diagram. We're able to use this information to not only inform our design, but we're actually taking all this data and inserting it into the members itself so that we can visualize that in Revit. Now, because we index individual framing members in our models, we're able to take this model from Revit, send it out to analysis, and then round trip that data right back in, resizing these members and making the steel data process automatic. Now that we have members sized, we're able to use this data in our model and calculate the embodied carbon by exporting this data out to an EC3 database. With these calculations, we're then able to import it into a Power BI dashboard. Here you can see option 1 is a 4-truss system versus option 2, which is a 5-truss system, and we're able to have that inform our design as well. But it's not just enough to have all this data in our model. We actually have to visualize the data. So this is a tool that we're demonstrating that helps us generate heat maps based on metadata. So the rows are zones, the columns are different parameters that we're checking. So this example right here, we can see the different types of members that we've indexed, truss top chords, bottom chords, verticals, diagonals. And why are we putting all this data into our models? Well, we do believe that it provides value to our clients and to our project partners. So, for example, we're able to export our entire model out into an IFC and then bring this into our construction engineering's model viewer. And so, external stakeholders, such as the owners, are able to verify this data in real time. Here, they're able to see what's locked and what's unlocked as far as what's being worked on. Here, we can see the schedule, what has been released for detailing, what's still under development and design. And all this is from a web app, so it's software agnostic. Anybody's able to go in who has access to this app and view that. And so this is the final result. After 2 weeks, I have to say 2 weeks was not enough time for us. Our first week was mainly spent coming up with an idea and then putting our team together of 9 designers across 6 offices and 7 disciplines. And if we had more time, I would have really loved to have brought in our construction engineering group early. They could have helped us to inform our design even more so and bring this up to a LOD 400 model where we have all reinforcing and connections actually modeled. Now, in the end, I will say that I'm happy with how much we accomplished in the short period of time, from planning, modeling to the analysis. It's pretty cool that we have such a data-rich deliverable. And in the next 5 to 10 years, I think this is what's going to be the deliverable. It's not going to be PDFs. It's going to be a data-rich model. So we're not waiting for that to occur. We're making that happen right now. We want to encourage other firms to join us in adopting this type of a methodology.
Wow. I really commend your ability to arrive to a design solution in such a short time frame period. It's exciting to see the stream of questions coming out through our streaming channels. I'm happy to relay one for you, Steve. What is a pressure impulse?
A pressure impulse diagram, yeah. So the pressure impulse diagram is basically looking at so in that aspect, it was basically a small explosive that would have been in a backpack at that corner, and the diagram is basically showing that if there was an explosion, what members of the structure would actually be prone to the impulse and the pressure from that explosion. And with that, we're able to that basically affects our design because we can increase the size of members, perhaps use additional reinforcing and whatnot.
Thank you. Here's another audience question. When faced with this type of project brief, which by the way is very complex, where do you start? How do you begin with a discussion, with a sketch, with a code, with a model? What's your starting point?
Yeah, so our starting point, like I said, normally people come to us already with a design in mind. With this one, what we ended up doing is we realized that we needed to design something. And so our Jared Friedman, who is he's one of our technical designers. He was very instrumental in actually coming up with some massings on the site and kind of looking at it from an architectural standpoint, looking at um, some of the other shapes around New York City, like the ferry terminals that we had there, the piers. Those were actually playing off a little bit of some of the other ferry terminals there in New York. So once he kind of gave us a nice idea. Then we were kind of able to run away with it. Again, we didn't have a lot of time to really dive down into the design of the architecture. So so normally that would not be the process.
Awesome. It looks like we have a couple of more minutes for another question. This is from William Myers on YouTube. Is it possible to quantify the savings in budget and resources for this project as opposed as similar projects prior to this advance in technology?
Yeah, so that's a difficult question because we didn't have a budget to begin with, did we? So to understand how much of the savings would be, budgets can vary widely. Sometimes you have a generous budget, sometimes it's very tight. I know in one project that we had worked on recently, because we used this whole process of generative design and the repeatable geometry, like I was showing, we ended up at the time of this video on that project, we were about 40% complete, but we're at 40% CDs, but only used 12% of our budget. So that's a pretty impressive story as far as going down this methodology.
Steve, this is really, really great work. I thank you very much for your participation in the Slam. I'm ready to introduce our second speaker. I'm honored to present you with Sean Quinn from HOK. Sean leads the sustainable design practice at HOK and coordinates performance design services across the firm. Sean is leading the integrated design team approach to sustainable strategies, including energy and environmental performance, and net zero energy and carbon. Sean, welcome to the Design Slam. How are you doing today?
Good evening, Cesar. I'm doing great. Thanks for having me.
Fantastic. Tell me more about HOK.
Yeah, sure thing. HOK is a global design, architecture, and engineering and planning firm. We have 1,600 team members that collaborate across a network of 23 offices in 3 continents. So we're a global design firm that needs to address globally evolving challenges. HOK designs buildings and spaces that respond to the needs of people and the environment. Our designers are rooted in technical excellence, driven by imagination, and focused on a solitary goal: to deliver solutions that inspire clients and connect to the communities they serve. HOK, through the role that I play in performance design and sustainability, uses building science and sustainable design strategies to create high performance, healthy, and resilient buildings.
Awesome. So you ready to show us what you've done for this Design Slam?
I'd be absolutely thrilled to.
Go ahead.
Excellent. So first off, just again, thanks for not only inviting us to the Design Slam, but for structuring that brief in a very complex way. And while obviously it's the intent of a Design Slam is to act quickly and instinctively, we are in this case addressing both some systemic challenges that we see in a changing climate, as well as those that will be evolving and changing over the course of the coming decades as a result of increased storm events, climate change, and a diversity of needs in the New York area, but obviously emblematic of those happening across the world. So in looking at Governor's Island, we wanted to strike out to create a climate park, a space that would be available as a place to unify people in the New York area to more open, accessible area, but also to serve as a living laboratory. Both to the park itself, as well as the Climate Change Center and Transit Hub, to the conditions and the effects that the changing climate, rising tides, and storm surges will have on buildings. And so to begin with that, we really need to understand all of the challenges that this is going to, that these problems are going to hit design teams with. And so we set out essentially a 1-week process in total for this Design Slam, from midnight of Sunday, about 2 weeks ago, to this past Sunday. And the goal here was first to understand our context. That storm surges such as Hurricane Sandy can lead up to about 13 feet of rising tides, and then in the worst case predictions of sea level rise through climate change looks at about a 9-foot rise by about 2100. So our goal as a practice needs to be to explore how a variety of land formations, resilient technologies, and building systems may be deployed across the site and across a building to prevent that systemic flooding, as well as the erosion that would otherwise lead to the reclaimed portions of the southern end of Governor's Island back into New York's harbor. And so our methodology quite simply becomes then a real understanding of those rising seas and those tidal forces, the stresses that they represent, both through hydrostatic as well as extreme wave forces. And then with it, to really think about and how to integrate ecosystem services, to move a little bit away from the gray infrastructure that we've seen traditionally in the 20th century to the essence of actually returning to natural systems that may be able to better withstand those events and are meant to evolve over time with those stresses. And finally, to create a methodology for resilient land, structures, and buildings. And so our E2 zone is this beautiful 20-acre site right next to, on Governor's Island, right next to the Yankee Pier on the southern end of the island. There are about a dozen existing housing buildings from the 19th century that are still standing. We want to create a hydrological park that begins to explore the influx of those changing tides and the hydrostatic pressure that comes with rising seas. The notion of actually combining the transit hub with the Climate Change Center is based upon a very simple premise. We need to gain greater access to Governor's Island, as well as access back to the surrounding boroughs of the city. But that a Climate Change Center is going to serve really well embedded within that structure to enable the exploration of how the forces that are right against the seawall are going to begin to affect this building. And so the notion here is that the building, the Climate Center, can really serve as a living laboratory. We not only want to explore the changes that are happening with climate change, but really the effects that they have on buildings. This issue isn't unique to Governor's Island or even to the New York area. These are systemic problems that we see in any coastal lying areas, and even in any water-bound developments, that those rising tides are going to lead to some form of erosion or creep on building structures.
Let me pause you here for a second, because there's a great question here for you coming from the audience. So it looks like the computational design is becoming the norm or the baseline expectation for a lot of these type of analytical processes. How does technology assist in the success of HOK product?
Yeah, absolutely. So, I mean, computational design is obviously bounded in the essence of being able to look at a multitude of different parameters and trying to create a singular solution from it. Trying to create a singular design from nine different stress points is a fairly complicated task. So computational design can be used to really rapidly explore through some of those. One of the challenges we see with computational design is being able to define those metrics really clearly, so we don't have an infinite band of it. And that's where, with our structural engineering group, products like Stream, and through the research of our sustainable design group with Climate Studio, we're really trying to investigate the best ways by which we can rapidly explore diverse and really complex geometric forms that reduce embodied carbon and also enhance operational energy, essentially trying to kill two birds with one stone.
Fantastic. I'm eager to hear more of this solution. Go
Sounds
ahead.
great. So our approach to the site then quite simply begins with what always seems to be a counterintuitive one, but one that's become pretty widely accepted. Let's let the water in. Trying to create a bigger wall is only going to create another structure that is going to be at some point or another by an outlier event likely to be overwhelmed. But what we can do is direct that water. And so by raising up these protective berms in the middle of the site, we can direct that flow of water. We can create a series of wetlands that begin to slow those storm surges and prevent erosion of the reclaimed soils on this island. Ultimately, we need to develop a program that begins to sort of house and sort of nestle itself at that intersection between the aquatic plane and the terrestrial. But for the building to act as a living lab, we want to monitor the effect of these hydrostatic and tidal forces on the building. But then also, as we began to explore further, it'd be good to look at how we could repurpose some of the existing buildings on this site. Ultimately, we want to explore some further energy solutions. And so how can we actually use climate change to our advantage? Harness the flow of the East River to actually generate energy across Governor's Island. And so as you see here, as we go from the very simple sketch to our VR model, you begin to see how we begin to shape the overall topography of site. We begin to create definitions around the areas that can be wetland versus transitional versus tree canopy. This sort of complex ecosystem of services intends to have the land and sea act as a sponge that is able to absorb, capture, and slow those tidal surges, and to reduce the amount of flooding and erosion that happens on site. At the heart of it is really then becomes an understanding of where do we want some of those floods to begin to influx into our site. So the higher high mean water table, just the existing current condition, we're about 4 feet below the seawall. The actual seawall is not breached until about 5 feet of sea level rise. So the first goal is to essentially erode actually the seawall around our stretch of site. Raise up that topography, allow the sort of mixed use development to grow, and then to sort of build out the building at the thrust point of that. The first existing building begins to get hit by that 5 feet of sea level rise. So it's actually sort of in the middle towards the back of that. And that as we hit 7 feet, the next two buildings begin to be absorbed by water. It allows us to essentially study that first building, leaving it untouched, understand how hydrostatic forces affect it, and then for those 2 future buildings to do a moderate or an extreme retrofit that enables us to really understand how we might be able to take a really typical approach to modernizing buildings, as well as a more extreme approach to deal with extreme pressures. Once we get to 9 feet of sea level rise, we have a different playing field. Quite frankly, that event is, as noted previously, is far too likely to be common as an every 10-year event, and in worst case conditions by the end of the century might become our new static condition. And as we know that people are going to continue to build in areas that will lie within that 10 feet of sea level rise, we need to really explore how new buildings begin to withstand not only those forces, but the long-term effects that a saline environment would have on building structures. And so I'll begin by looking at how we build resilience through retrofit. The goal here is to essentially look at how these higher wind loads and sea flood loads that can comprise 5 to 10 times the amount of force that a normal structure is designed to handle can be retrofit to begin to deal with some of those extreme conditions. And so the 5 existing buildings that remain within the climate park act as a feature. They can serve as a teaching tool to the impacts of climate change on the built environment and the options for addressing them. So the first building we leave to be untouched, that it will begin to actually be intentionally flooded with 5 feet of sea level rise. This enables us to study the existing building and the technologies and how they essentially react to those changing tides. A moderately reinforced building is meant to really address how we can affordably create minor updates that enable a building in its existing state and purpose to withstand some of those imminent pressures. And over time, looking at some of the more heavy retrofit options. How can we provide future life to these structures through heavy reinforcement, additional levels, and that these future retrofit options are those that are then able to take on the best of both of those options. And so the moderate reinforcement is really based on common principles. Any type of hurricane proofing that you might do typically just results about a 5% increase in the cost to the building structure as a whole. The notion is essentially strengthening the foundations for increased wind and flood loading, wet flood proofing for the building, and updating some of the external skin. The more extreme major retrofit and reskin is around not just the reinforcement of those conditions, but really trying to actually expand the building and allow it to load up to deal with hurricane level forces, 150-mile-per-hour winds and beyond. But we know that not only would any of these individual buildings serve as a nice observation point to understand those conditions, but that there are a variety of other conditions across the East River and Red Hook, in Lower Manhattan and in Jersey City, by which we need to understand more appropriately how building foundations, columns, and beams begin to essentially creep, deform, or settle as a result of those incoming pressures. And so what we'd like to do is create a series of what we've jokingly called Terracotta Warriors, essentially these floating sculptures that would be embedded within the lower lying areas of that topography. Place sensors on them so we can evaluate the performance over time of geopolymers, basalt rebar, carbon cure concrete, coatings, and other performance enhancing methods. What gets really exciting and the real kind of critical focus for us for the majority of the sort of 4-day active design charrette process was looking at the Climate Change Center and Transit Hub. And I think it comes to the sort of the crux of sort of the mission that we have with the Design Slam. How can we take a multiple diversity of talents, disciplines, skill sets, and tool sets in order to design a building in a very rapid period of time across all of these different metrics? And so beginning from the initial brainstorming, sketching on concept board, ideating with a diversity of a team, to initiating design across different modeling sculpting softwares, to analyze that for its structural integrity, as well as some of the intense forces that we need to take to address embodied carbon as well, onto the environmental analysis. How do we not only incorporate better daylight and natural ventilation into the building, but actually generating net zero energy building? And finally, visualization. A really critical piece of this process by which we begin to tell the story. Advocacy becomes one of the most important tools in any designer's belt, that we need to serve as not only a provider of a response to a brief with a client, but the opportunity to demonstrate some of the challenges that they may need to face, whether they realize it or not. And that visualization process enables us to show a real depiction of sea level rise early on.
Excellent, Sean. I'd like to pause you here for a couple of questions. From the technology perspective, in a landscape of a wide range of competing design technology solutions, what differentiates you from other firms? How you define HOK's ethos approach to technology?
Yeah, sure thing. I'd say that HOK is unified by the building smart, a foundation and methodology really initiated by our former chairman Patrick McClamey, and that really kind of evolves in the final execution of the delivery of projects through BIM, most likely Revit, but in the full spectrum of a project, from ideation to execution, a lot happens. And the 4 days that we initiated on this project, we utilized over 20 different digital design tools. And so our advanced design technology group has, two key functions. Number one is the enviable task to work across every different discipline, understand the different needs of the individuals, to find the right ecosystem of tools that we can draw from. And perhaps the less enviable task of making sure that all of those different tools communicate widely with with each other. And this is a common challenge I think every design institute faces, Autodesk faces, that we are to a certain extent creating a Tower of Babylon out of different software tools, but we have this wonderful diversity by which we can identify and solve for all of these different challenges. So ultimately, that really kind of leads to the key piece of our ethos, which is that we have an awesome cross-section of culture in our team. And we want to make sure that we put the right tools in the right hands. And so that's based more on the individuals that join HOK than any sort of mandate we have internally to follow a specific tool. But the ultimate success of that digital practice comes from being able to deliver these designs, solve for these metrics fluidly, accurately, and precisely. And that comes through the coordination across these disciplines, experience, and mindsets.
Very well said. I have another interesting question here coming from somebody in our audience representing a young generation. What kind of technical competencies you look in design professionals that may align with your digital culture, and what they can do to get ready for the challenges of these complex problems addressed by technology?
Yeah, so what I'll say, what we most typically expect out of most of our young designers and our emerging professionals is that they be multifaceted. We want people to be creative in design, excellent in technical execution. And so it's really useful to have a diversity of different tools that can enable design, but mostly a flexibility to adapt to the different cultures that any design studio gives you. And then overall proficiency in Revit, that ultimately, either by code or by our own practice, we're going to be expected to deliver a BIM model at the execution of a project. So anyone emerging from school should hopefully be interested in working from the start of a cool competition like this, but also figuring out how every single nut and bolt goes together. While we worked on with 20 different tools over 4 days, you can only imagine what would happen over the realistic 4-year time span that a project like this would take to execute.
Awesome. And before continue your story, I have a very quick question from a person in our streaming chat line. Joshua Nelson is asking, does living buildings and intentionally allow them to float? It's a realistic, good plan idea?
Yeah, so I think in particular for this site, the 5 existing buildings are currently unoccupied. So the goal of leaving them in place is to study the impact that sea level rise has on them. What we know is realistic is that all of Lower Manhattan, Red Hook across the way in Brooklyn, as well as much of the New York Harbor area, as well as many coastal lying cities, all have existing buildings that are occupied, that are in the same harm's way. So the purpose of creating a climate change research center shouldn't just be about the building. It should be about the park. It should be about how we understand how ecology can help structure landforms to deal with sea level rise, as well as buildings to respond to it, both the existing as well as a future design element.
Great. I'll let you continue with your story. Fascinating work.
Great, thanks, Cesar. So really, one of the apologies, one of the things that happens with design technology is it sometimes fails. I have a wonderful video that introduces the dozen folks that are imaged here. They all represent architects, engineers, environmental and visualization specialists, but all unified by a real focus on design. Everyone introduced themselves from New York, San Francisco, Atlanta, and one of the jokes that we all were going to share is was either our first or our favorite design tool. Mine was, I think, my first design software tool. I was probably about 10 years old, programming in Logo. We go as far back as using AutoCAD R12 with our structural engineers to Revit and Dynamo more commonly now. Max and Unreal for visualization, and I think even an allurement to the use of Sims as one of our early design inspirations. And I think a multi-generational challenge that flows there is to which version of Sims we're talking about. But these individuals represent more important than the design solution or the tools, but it's the different cultures and personalities and lenses by which they all focus on design problems. And that helps us get to the next phase of this, which is solving a multitude of design challenges in one singular area. So trying to create a climate center was based around the idea of being that living laboratory, that this building could sort of, the building structure would serve as a reference of how buildings may be resilient to hydrostatic pressures, tidal surges, and extreme winds. Very simply illustrated here, my hand sketches, which are then beautifully sort of translated through the programming work of Rafael Gavianes and the design sculpting work of Weijia Wu, that we need to then go from the thick black marker to not only a program that works and fits, but that meets the sculptural identity that's being attempted here. And the translational work that our design technology manager, Francis Sebastian, did to connect between Rhino and Grasshopper and Revit and Dynamo through the use of Speckle and other design tools. But the focus of the building is that in 2020, we want to have a pretty typical ferry terminal on the ground level, and on the second floor, a climate change research center. As the tides begin to rise, that program flips. The research center actually submerges to really explore the impact that those tidal surges have on the building structures and materials, while the ferry terminal rises with seas, and that second floor concourse, or the second floor office area, becomes a concourse out to the ferry piers. The third floor stays as an exhibition center and an observation level to begin to look over all of Governor's Island, as well as New York Harbor. And so as we begin to look at that sculpting work, begin to look at how the vault became a real driving form for our design, we began to sort of integrate sort of almost this notion of a glacier, that the building, as sea levels would rise, would almost represent the changes happening in other parts of the world. The 15,000 square foot PV canopy, the roof of this building more than supplies the necessary 23 kBtu per square foot per year to make the building net zero. The next is to then really kind of prove, well, is that the right form at all? And so our structural engineering group is wonderfully creative to not only explore through the use of Kangaroo and other Grasshopper tools how best to sort of optimize this form, but really to begin to understand the multitude of stresses that this building is going to take. Thrust and gravity loads, not to mention space, aesthetics, costs, embodied carbon, and of course the external forces. Visualized here is the continuation of that vault if it was a unified shell. And then through an SAP analysis that begins to create a ability to sort of visualize the balanced and unbalanced stresses of the vault, that the long spans and tension rings will have a few weakness points that need to be reinforced. But for the most part, the notion of a vault actually responds fairly well to the lateral force loads that this building is going to need to take. And speaking with Anders Carlson, he kind of noted that it was like trying to squeeze an egg, that essentially that tidal force against the building was going to enable it to be structured really well. And with Matt Bridenthal and Daniel von Briesen, the ability to then structure really rapidly and quickly some of the structural notions and ideas that begin to bring reality to a very computational design form. Patricia Piedrafita, one of our environmental specialists, began looking at some of the typical notions of solar exposure over the building, as well as computational fluid dynamics for extreme wind forces, as well as how those begin to bring daylight into the space, as well as natural ventilation. All of this enables us to get a more granular understanding of both the sort of environmental challenges, but also the opportunities that we have here. By relying on a concrete-based form and a thin-shelled vault, we can really sort of take the advantage of that sort of concrete mass as a thermal ingredient. Integrate that with radiant panels that can serve both hot and cool water that maintains comfortability for the extreme events of summer and winter, and allowing natural ventilation and the removal of that cool or heat through those radiant panels throughout spring and fall. And so we get a very low energy building, not only because of an advanced system, because of the complement that it plays to the structural systems put in place. And so that comes down to really the true metrics of building. And so while we're trying to solve a very complex challenge of climate change resilience, we also want to make sure that this building represents the ideal of what building should be. A low embodied carbon, as well as a positive net energy building. And so Devki Desai worked really closely with the structural engineering team, with our design team, to explore a host of different structural materials, fiber reinforcement, and to cast thinner and reduce the material quantities, and a geopolymer concrete that could lead to a 50 to 70% reduction in the embodied carbon. And that gets us to about a 70, that 70% reduction point is fantastic. And that's then made up partially by some of the research that Max Driscoll and Blanca Dazi Espouge did in the sequestration that the ecosystem services could do, that the landscaping itself could capture an additional 10% of the carbon that's left. I did the energy modeling with an insight, which essentially targets out an energy use intensity, or EUI, goal between 18 and 22. The PV, as I said, makes up about 26. So we're already net positive. But the notion of actually trying to create that sort of centrifugal form enables us to take advantage of some of the tidal forces in the East River. If we can capture even only a portion of those 4 knots of typical flow, let's imagine about 1.5 knots conservatively, we can generate a 500 kilowatt hydropower station inside of this building. And so as sea level rises, we can actually convert that into energy to service the development that's risen onto a higher berm. And while all of that's really exciting, it's the narrative that comes down with almost working with any client, as well as the unification of all of these different ideas, stresses, and analyses into a final form. Rotimi Sariki is an amazing visualization specialist within our team and is able to bring to life the narration of this story. And that one of the things we haven't really begun to analyze most efficiently is, what does it look like to have sea level rise begin to influence some of these spaces? And through a series of very simple visuals, and then through a VR module, we're able to explore how over time, a series of pedestrian bridges goes away and sort of transforms all of the secondary nodes of travel to a primary node of travel by ground, and the exploration of different aquatic sports in its stead. That as we pan out into the development, the wetlands can provide another means of a groundscape instead of the more traditional lawns associated with most parks in the New York City area. And that ultimately, to really imbue the sort of long-term resilience in these flood-prone areas, we need to accept that portions of this development will be inaccessible for times of the year, and we should celebrate that through a multitude of pathways that enable a diversity of experience. And so while we want to mitigate as much as we can the impacts of climate change, we should celebrate the transformation of our land as best possible while being as resilient as possible. And so I'll close with the final image, which just begins to then again look at what Governor's Island Climate Park can begin to look like, not only as a representation of the opportunity that Governor's Island has, but the opportunity that we have as an industry to begin to identify and really address some of the systemic challenges that we see facing the AEC industry, as well as the general populace and cities around the world. It takes someone coming together to present a big, hairy, audacious task. So I thank Autodesk for doing that. But I really want to thank both my team as well as teams everywhere around the world that are trying to address these issues, whether it's through a 4-day sprint, a 4-month exercise, or 4 years or more of trying to create resilient ecosystems in the cities and places of nature that we love to live in. Thank you.
That is fantastic, Sean. I am really inspired by the way HOK is utilizing tools to address these really complex problems. I think we have time for a couple of questions, and I have to ask you this. What can software companies like Autodesk do better to equip designers with tools that allow you to solve these increasing complex challenges? We can see Governor Island embodies very important impacts like rising sea level, affordable housing, public policy, environmental justice, all of these factors are increasingly on the palette of variables that an architect needs to address.
Yeah, I think the biggest challenge from an execution side, from a digital tool execution side, is that the ecosystem of tools has gotten broad and varied, and part of that's wonderful. It's a fantastic renaissance of being able to pick from just literally hundreds of different tools to answer a singular question. But what's really challenging is sort of bringing together those different designers, especially across disciplines, across different stages of a design, to not need to sort of reinvent a lot of that work or do a tremendous amount of translational work. We've seen some of the opportunities previously through Flux, now with Speckle and Revit inside, or Rhino inside Revit, that begin to look at how do we begin to marry disparate processes and tools that might be within Autodesk environment or not into a more fluid design interface. The more that we focus ourselves on matching tools to the talents of individuals and their experience points, I think the more we're going to be able to execute these ideas fluidly. Issues like climate change are not resolved by any individual's ego over physics or any singular idea. It takes bringing together multiple people with different experience points, with different mindsets to solve those challenges. And I think, you know, to Autodesk and to any software company out there, it always needs to be predicated on the notion of coming together to solve a singular problem that impacts all of us if we don't solve it.
Good answer. And probably we have room maybe for one more question. This is from the audience. Can you speak of the results of embodied carbon quantification as well as the carbon footprint over time?
Say that one more time.
Can you speak of the results of embodied carbon quantification as well as carbon footprint over time?
Yeah, sure thing. So, I mean, the embodied carbon of a building is twofold. First, it is all the work that is done in that first 3 to 4 year construction process. In this project, we've tried to address that through a concrete form. And now, while concrete notoriously is probably one of the worst building elements for embodied carbon, our team has done a lot of research in the advancement of different technologies that begin to reduce its embodied carbon. So Carbon Cure is a good technology out there that looks to actually embed carbon sequestration inside of those elements, replacing some of the aggregates with actual carbon features. Looking at thinning that concrete, looking at different fibers that begin to try to disable any creeping or cracks, while ultimately resolving in a lighter form. And so concrete in this case becomes an example where we can actually enact a 70% reduction in that sort of first initial resolvement of the project. Over the course of 30 years, the landforms that we are developing replace another 10% of that. And so we still have 20% left to get to carbon positive. And that we hope to make up through the PV energy, for which we have at least a positive 4 kb2 per square foot per year. That begins to essentially negate the ultimate carbon picture of the building over 30 to 50 years.
Fantastic. And I think with that question, we are ready to close the session. I want to thank you really, really much, Sean and Steve, for sharing your amazing work and show to the world how your design process and design thinking getting us closer to a resilient and sustainable future. Thank again for being our guests, and looking forward to hear more about your future solutions. And thanks everyone for attending this session.